So now we're going to talk about roots and radicals. This is on our section right before we're going to talk about solving quadratic equations using the square root property and the quadratic formula. So definition of a square root, b is the square root of a if b squared equals a. So for exercises 1 through 3, this asks us find the square root of 64. So you're trying to find what number times itself would be 64, and that number would be 8. So the square root of 64 is 8. Similarly, 5 times 5 is 25, so 5 would be the square root of 25. And for this one, well, 9 times 9 is 81. 1 times 1 is 1, so the square root of 1 over 81 is going to be 1/9. Now our notation for positive and negative square roots, the square root of a is the positive square root of a. The positive square root is also called the principal square root. Negative square root of a is the negative square root of a. And of course, square root of 0 is 0. And just note, a negative number cannot have a real number as a square root because no real number, when squared, is negative. So when they ask us, what is the square root of 121, the way we write that mathematically is this way. And the square root of 121 is 11. Similarly, with the square root of 49, this is how we write it mathematically. And then the square root of 49, that's 7. So here we're doing the same thing. Now they're getting a little bit more complicated. So if you're not sure, you can always whip out your calculator. And we can go ahead, we can do the square root of 0.25. Hit enter, and we see that's 0.5. If we do this one, what we'd enter that is do our square root, do our fraction key, 49, hit our down arrow 144, hit the right arrow a couple times, and hit enter. Notice that gives us 7 over 12. So notice if you're taking the square root of an entire fraction, the same thing as taking the square root of the numerator and then taking the square root of the denominator, and then writing the numerator over the denominator. Now it's very important here when you're working with square roots, if you have any addition or subtraction underneath the square root, you need to do that first. So here we need to add 144 and 25. That gives us 169. And then we're going to take the square root of 169, and that will give us 13. Now, simplifying square roots when the radicand is not a perfect square. This is how you would do it by hand. You'd first find the prime factorization of the number under the radical. And by the way, the number underneath the radical, like this 49 over 14, that's called the radicand. And this symbol we're hearing, the square root symbol, is called a radical sign. So when they talk about find the prime factorization of the number under the radical, that means find the prime factorization of the radicand. Circle pairs of the same factors you found in step 1. For each circled pair of prime factors, write one of the two of those factors outside the square root. Write any factors that are not circled under the radical. Multiply the factors outside the square root and multiply the remaining factors inside the square root to get your answer. So if we turn the page, they have an example. We have the square root of 360. Well, 360 is the same thing as 36 times 10. There's 36 is 6 times 6. 10 is 2 times 5. And then each of those 6's, well, 6 is 2 times 3. So if we count here, we've got 1, 2, 3 factors of 2. We have 1, 2 factors of 3, and a factor of 5. So I see a pair of 2's I can circle and a pair of 3's I can circle. So for each circled pair, I'm going to put just one of these out. So I'm just going to put 1, 2 out here, 1, 3 left out here, and then my leftovers would be 2 times 5. So on the outside, that gives me 2 times 3. That's going to give me 6. 2 times 5 is 10. Now you may have noticed up here, if I at the outset, I've written that as 36 times 10, you might realize, well, wait a minute, I can take the square root of 36. So I can split them apart. Square root of 36 is 6. So that gives me 6 square root of 10. Same thing we got here. So the key here is to find factors of this that are perfect squares, like 4, 9, 16, 25, 36, 49, 64, so on and so forth. So let's try simplifying. So here we've got square root of 20. That's the square root of 4 times 5. And then 4 is 2 times 2. Well, there's my pair of 2's. So I'm going to go ahead and put that 2 out in front. And then I just have 5 left there. And notice if I take the square root of 4, that's 2. So that would be my answer. Let's look at 28. 28 is 4 times 7. And I can kind of do the same thing with the 4 as we did in the last problem. Well, there's a pair of 2's, so again I'm going to write 1, 2 out in front. Another way I can think about it again is if I can take the square root of 4, that's 2. And then my square root of 7 is what's going to be left over, so I get 2 square root of 7. So let's do 45. 45. Well, that's 9 times 5. And 9 we can break down into 3 times 3. So I have a pair of 3's. So I'm going to put my 3 out in front. 5 is my leftover, so that's going to go underneath the square root. And that will be our answer. Now, if you have this calculator will do this for you. So if I type in the square root of 20, notice it simplifies it to 2 square root of 5. Likewise, square root of 28, 2 square root of 7, and the square root of 45, 3 square root of 5. So now we need to deal with an issue we've been kind of avoiding up to now, is how do you deal with a negative underneath the square root? So this is going to be simplify complex numbers in terms of I. And we're going to define an imaginary number I as the square root of negative 1. So now we're moving beyond the real numbers. This is not a real number. And this has a property that when I square I get negative 1. So if b is a positive real number, then the square root of negative b is equal to I square root of b. And so by writing in terms of I, we can get the negative out from underneath the square root and then allows us to simplify. So if I look at this first problem, I see the square root of negative 100. So my first step is to rewrite that in terms of I. So put my I, and that gets rid of the negative. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be 10i. And then square root of 100 is just 10. So this would be Same thing here. I'm going to write that in terms of I. Gets the negative out from underneath the square root, then square root of 36 is 6. So I'm going to end up with 6i. And on this one, again, write in terms of I. This time I can't simplify the square root of 6 any further, so I square root of 36 is going to be my answer. So let's turn the page and let's see how we would work these. So now we're kind of mixing two things. Want to simplify each expression in terms of I if needed. Write each expression in terms of I, and if needed, simplify. Okay, so first thing I do is anytime I see that negative in the square root, I'm going to write it in terms of I. And then that's 75 is 3 times 25. So if we're doing this by hand, that'd be 3 times 5 times 5. I have a pair of 5s, so I'm going to put a 5 in front of the I. And then leave the 3 underneath the square root. Let's look at this next one. So I'm going to write this in terms of I. "48 is 16 times 3. And so I'm not going to write this step out anymore because square root of 16 is 4. So I'm going to put that 4 in front. Bring down the I, square root of 3. Now if you're doing this on your calculator, when I do the square root of 75, so I still have to write this first step. It gives me 5 square root of 3. You just need to remember to put the I in here. Same thing with the square root of 48. Just remember to put the I after the 4 before the square root. Now, there's a negative on the inside and a negative on the outside. The negative on the outside stays put. So this negative comes down. This negative underneath the square root, that becomes I. And then square root of 16 would be 4. So that's going to give us a negative 4i. Let's try number 17. So again, I write this in terms of I. But the square root of 49 is 7, so this is just 7i. And then let's do this next one. So again, I write in terms of I. So again, the I gets the negative out. 50 is 25 times 2. And the square root of 25 would be 5, so this would be 5i square root of 2. Now, in number 19, there is no negative underneath the square root. The negative's on the outside, so we're not going to have I here. We're just going to start working on simplifying this. 72 is 36 times 2. Square root of 36 is 6. So this gives me negative 6 square root of 2. Now if we look at number 20, I'm going to write that square root of negative 8 in terms of I. Now the square root of 8, well, 8 is just 4 times 2. So when I break this down, that breaks down into 2 square root of 2. But then you have this 4i here. Since there's no operation indicated here, the operation's multiplication. So I want to multiply the 4 with the 2. And that's going to give me 8i square root of 2. Let's look at this next one. So again, I first write this in terms of I. Now 18, I want to write that as 9 times 2. I don't want to use 3 and 6 because neither of those are perfect squares. And then if I take the square root of square root of 9, that gives me 3. So that gives me 3i square root of 2 over 3. But then these 3's divide out. And so I'm just left with I square root of 2. Looking at number 22, again I'm going to write this in terms of I. $54 is 9 times 6. Square root of 9 is 3, so I get 3i square root of 6 over 6. Now I'm not allowed to cancel out the 6 because this 6 is not underneath the square root, but this one is, but I can reduce the 3 over 6. So that's going to reduce to 1/2. So that's going to give me I square root of 6 over 2. So if I was doing this on my calculator, after I've written this step, I would do my fraction key, my square root key, hit my down arrow, put my 6, hit the right arrow, and hit enter. And there's my square root of 6 over 2. I just need to attach an I to it. Alright, so let's talk about simplifying expressions now. And key here, if you got more than one term here, wherever you divide here, you have to divide into both terms. So typically what we do is we go and we factor out a greatest common factor. So I notice in the numerator I have a common factor of 5. So I'm going to factor that out. It's going to leave me the negative 1 plus or minus 2 square root of 2 over 10. And then looking at 5 of 10, we can reduce that to 1/2. So that's going to give me a negative 1 plus or minus 2 square root of 2 over 2. Now you might be asking, can we cancel out the 2's? No, we cannot do it here because we also have to divide it here. Now if you really wanted to cancel out the 2's, you would need to divide that into both terms. So let me put or. I can do a negative 1 over 2 plus or minus 2 square root of 2 over 2. If I write it that way, then I can reduce the 2's. And so my alternative answer would be a negative 1/2 plus or minus square root of 2. And you'll just have to check on some problems they'll want it written in this form, and some problems they'll want to write it in this form. So let me draw a line here. So let's try this next one. So I'm looking at 32. Square root of 32, well that's 16 times 2. Square root of 16 is 4. So it's all going to be over 10. In my numerator, I've got a greatest common factor of 2, so let's factor out the 2. And then I'm looking at that 2 over 10. I can reduce that. So that would give me 3 plus or minus 2 square root of 2 all over 5. And if I wanted to write it out separately, then I'd write it out as 3 over 5 plus or minus 2 square root of 2 over 5. So that would be our alternate answer. Now, let's talk about for a minute when we're actually able to completely simplify a square root. So like here, this square root of 25, I can completely simplify that into 5. Square root of 25 is 5. So, and I'm actually able to combine the stuff in the numerator because there's no radical left. So remember, this means that we have negative 2 plus 5 over 4 or negative 2 minus 5 over 4. Well, this would give me a positive 3/4, and this would give me a negative 7/4. So I actually have two answers here, negative 7/4 and 3/4. All right, so now let's bring in the imaginary numbers. So first thing I want to do here, since I got a negative underneath the square root, I want to rewrite that in terms of I. So that square root of negative 8 becomes I square root of 8. And then remember, square root of 8 is the square root of 4 times 2. So that's going to give me 2 square root of 2. I just need to include the I. So that becomes a negative 8 plus or minus 2I square root of 2 all over 2. And so now I can divide each term here by the 2. So I have to make sure I do it to both. That's going to give me a negative 4 plus or minus I square root of 2. And then we do something very similar on number 27. So that's 12 plus or minus I square root of 64 all over 4. But the square root of 64 is 8, so we get 12 plus or minus 8I over 4. And then I just need to divide each term here by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So my answer here is going to be 3 plus or minus 2I.